Oh, awesome. No, thanks for having me here. It's exciting. This is my first year at OCP, and I've seen a lot of exciting stuff. I was asked last week actually to give this talk here about what we've been doing at Adobe with regards to white box switching and trying to get into a more open compute kind of world. And so this is called Project Greenfield. It's building the Nextgen data center at Adobe. It's really about optimizing application delivery inside the data center, inside the Legacy Datacenter. So yeah, let's get into this. So let's talk about the ideal world real quick. Obviously, we have the application developers, and what they want to do is go from idea to production as quickly as possible. So they go through that whole iteration. They code, they test, they QA, they package it up, and then when they go to throw it over the fence to production, at least in our data centers, the world doesn't quite work that way. There's a lot of complexity involved in getting it up and out there. They need to scope what kind of servers they want, and so we have different applications that are out there, and they might go, oh, we want the Ferrari of servers, and these other guys want the Maseratis of servers, and so you have all these applications out there, and they all have their different needs and wants. And so they get their orders in, and the next thing they have to do is they got to reach out to the DC Ops guys, and they're going, hey, we got to rack and stack all these servers, so get your tickets out. Talk to the networking team. Hey, maybe you need a new VLAN. You need to get your access ports turned up. Maybe you need some VIPs. Let's get some internet access in there. Then you got to configure, install, and then you're finally ready to get the application installed in the server. This whole process can take weeks to months. And that's kind of the big problem, because the alternative is that they can just go to the public cloud. You've got your infrastructure as code and Terraform, just throw it out there, and a few days max, you probably have your application in production. And so what we're trying to do in our data centers is trim down the amount of time that it takes to get from application inception and development out into production. And so we go through and we kind of evaluate what the limitations are, and it all kind of narrows down to data center and network inefficiencies and what can we do to optimize that. So we have the Legacy Data Center. It's kind of the yesteryear network design. It's all pairs of devices. So we got pairs of border, we got pairs of maybe a border aggregation, pairs of firewalls and load balancers out there, pair of core, dist, and the whole access layer. All in all, that kind of model is an inefficient use of resources. You've invested in these pairs of devices, and you're only really using half of those resources because maybe you're using SDP there. One side's active, the other side is waiting to be used. So you've made this investment, half is being utilized. So that's a bit inefficient. The whole core dist model doesn't bode well for the east-west high-speed transfer weights, which is kind of where these newer applications, containerized application workloads are going. You've got Hadoop and all that stuff. So when you throw one of those jobs up there on highly oversubscribed model, you start melting the network down. We've seen that a lot of times, and for years. And as you continue to grow through data centers, each data center kind of has their own look and feel to it. It's really hard to automate that. And so, all the configuration has been pushed out by hand, typically. And this is, the years of yore. Well, that's not really years of yore, like 5 years ago or so. Yeah, so all this manual stuff, there's mistakes. It's really hard to figure out what the iterations are from data center A to data center B. And that's a big problem, because now what are you going to do? You can make a database of what all of your differences are. It gets madness when trying to automate that stuff. And so say you want to go to the lower levels, even on the server side of things, you have a bunch of servers, and it was probably easy to manage. You had a VLAN or a couple VLANs, and now you have this whole model where everything is spread out. You've got your distributions, and you've got servers all over the place. But now you have one server on a VLAN over here in application A, and they need to talk over there to application A as well, and this all on the other side of the data center. Again, we have the oversubscription problem, and then you talk to your vendors, and they go, hey, what can we do? Because these are the big box switches. What do we do to kind of solve these problems? And so you go to lunch with them, and they go, yeah, we can solve all your problems. So all you need to do is implement these proprietary protocols, and we can get your VLAN reach throughout the data center. And while that happens, you implement these new protocols, and it actually opens up your ability to use both of the cores. But again, you're now married to your vendor, and that's overall kind of a problem, in my opinion. I think using multi-vendor is a good thing. We use multi-vendor as far as the load balancers are concerned. But again, if you're doing non-automated deployments to these guys, you have an issue with automating. And if you have a unified way to kind of communicate with all of these things, some abstraction layer, then that makes it simple. But again, if you haven't started with automation, a good framework in place, that's the big problem that we have. OK, and so let's look at the servers as well. Again, each product group thinks that they need what they want. So you allow them to buy the servers that they need, and that's great. But oftentimes, all these servers in the legacy environment, you have the monolithic application, and you dedicate a server for a specific task, or you specify, you dedicate a VM for a specific task. And so you install all the packages on that, and it's just sitting there. And you might not know what the real use is on that server when you're building your app. And so I know we have a lot of services in our data centers that, SQL services, web services, dedicated servers, and they might get hit a few times a day. And I think that's a huge waste, and it's a big problem. I really don't believe that the application owners should really be in charge of the server acquisition process. I think that should be kind of in the hands of the data center operators, and we provide them with the knowledge of how to, what the overall utilization of the systems are, and then they can kind of try to scale appropriately. Because when we're at a big scale like that, everyone thinks they know what they want, and then things get lost in transit. It's just a big headache. And another headache for the data center guys is that you need to maintain a huge spare parts depot. I won't tell numbers of what we spend on replacing spare parts, but it's huge. Fans and power supplies, and I'm not going to talk about disks and stuff because that stuff's going to fail. But yeah, just keeping the depot on site is rough. And I feel bad for the data center guys too, because oftentimes they're at the mercy of the operators. So we have a failure in the data center, or server failure. Application group goes, well, something's going on here, but I need to move services off, and maybe it's just a disk failure, nothing crazy. But I need you to be there late at night to just pull a machine out and do stuff, and that's not the business you want to be in. So something needed to change. And at Adobe, that was called Project Ethos. And so Project Greenfield and Project Ethos kind of rolled side by side. Ethos is an application, containerized application deployment mechanism that we built internally. And so it's basic stuff, or a lot of people are doing it these days. You have your code repository. You have a tool that brings it in, containerizes it, allows you to allocate resources, and does security checks against it, and then pushes it out to your orchestration layer. And so we've got orchestration layers running in Azure, in AWS, and so you just go and select, hey, I want my application deployed here, and it's out there. We didn't really have anything in the private data center space, though, and so whilst we were working on that, we decided why not kind of go into the white box switching space and see if we can build a higher speed network. And so I know a lot of people are familiar with the CLOS design. And so all I really knew going into it is what I wanted the capacity to look like. And so we chose 100 gigabit at the spine layer. And for the access layer, we choose 10 gigabit for the access and 40 gigabit for the uplinks. We have VRFs there to segment public routable space from private routable space, and so that's what we have there and there. We do BGP within the CLOS, and we do the IPv6 auto configuration, so it's really simple to bring up all of your peering relationships. For all the servers, we've set it up so that we have, a rack full of servers consists of 44 servers, 2 tops of racks, and a management switch. There's 22 servers that go into the top of rack. And so we have, I believe it's a 1.6 to 1 oversubscription ratio throughout the network there. So if I want to reach from access 1 to X, that's a 1.6. We've put the load balancing within the top of rack as well, and that's the only kind of component that has access to the public and the private IP space. And so what we've done is kind of simplified things as much as possible. /27 at the top of rack, like I said, BGP everywhere, auto configuration, try to minimize the protocol stack that we're using. And that was, we've got there. It's good. And the great thing is that the chips are cheaper, the hardware is cheaper, all the bandwidth is increasing, so you can get really cool stuff at a much cheaper price than you can get from the big boys. And so since we're kind of starting fresh, the ability to automate the installations and post-configuration is simpler. It's running Linux, and so we've got 400 people, at least in our organization, that know Linux, and we can up-train them or get help from our current network engineering group to fill in the gaps as far as our networking issues might be. And so I had to include this because I just love this. This is inspirational. This is the Facebook class here, and so wouldn't it be awesome to kind of grow to that scale? Yeah, I'll go back to you if you want to take a picture of that. And so now, like, the servers evolved. Since we're now dealing with an orchestration layer to handle all of your application deployments, we move away from servers as pets, so we don't have Chester just kind of sitting there idly doing nothing. We have them all kind of working together. You use the underlying orchestration layer to kind of figure out, to kind of figure out what your resource allocation should be. So you just need to throw your application out there, your container out there, and Mesos or Kubernetes or whatever you're using kind of understands what the whole pool of servers are and just deploys it where it need be. It takes care of your failure recovery situations, and yeah, things just run. Another nice thing about this is we can get metrics from the whole cluster and put that in the hands of the data center guys. And so at that point, we know overall what the use case is. We can get a better understanding of what each container application is doing, and that's really important from with regards to taking that power or the desire from the application team to want to own the servers and putting it in the hands of other people. At least I feel, or the data center guys, because then they can look at those numbers and they can go, well, we know what we're using right now, and we can project that growth outwards. And so let's say I need some racks, we can be ahead of the game, get some more racks in, and get it all installed. And so how did we get there, and what did we learn? We had a simple evaluation criteria in what we were using. It was faster, better, cheaper. Choose 3. Normally you choose 2, but we wanted the whole kit and caboodle. And so, what's that? On the server side, we just sent out a bunch of RFQs to as many of with the vendors that we knew. We got a whole bunch of responses back, and again, listening to the criteria, they were looking at the criteria. We were able to eliminate the majority of those guys because they weren't in the price range we want. We wanted fast CPU, loaded up on memory, massive disks, bring it to us, and so they did. And we have ultimately pulled in a few vendors, and what we did was then put them under load and installed our platform on it, loaded it up, and everything performed as we would expect. It's fast. And so then we were talking with ourselves, well, what can we do to really differentiate it all? And it all boiled down to power consumption. And so we chose 2 vendors which pulled the least amount of power under the heaviest load, and that was the deciding factor there. On the networking side, we took a different approach. I knew that the big chip vendors, Broadcom, Mellanox, I really went for what types of switches would perform the tasks I wanted, and that was just mainly the speeds that I wanted. And we were working with the SnapRoute guys, and they already had an existing relationship with EdgeCore, so they kind of brought in the EdgeCores with the models that I wanted, and we got it up and running, and it was good stuff. And so at that point, knowing that the hardware it was the simpler thing, we needed to kind of evaluate what the network operating systems were. And so we looked at SnapRoute, we looked at Cumulus, we tried to get Ethos out there, but they weren't really available to us. Not sure what happened there. But yeah, and so ultimately, we ended up going with Cumulus just because it was a bigger name that we could sell to the organization, and it's an easier transition. I mean, I know the direction that I wanted things to go is that way, but being able to sell like Cumulus as a brand was easier than the SnapRoute path, and being able to transition to the similar CLI, we could bring the network guys in and do that. And obviously, it's running Linux. And so we chose Edge Core as well because we had them in and we're familiar with that at that point. And what was I going to say? And so for the Edge Core models that we use the 7712 32X for the spine, the 5712, 54X for the access, and we use a bunch of 4610s for the management layer. And it all just works. It's great. And we've currently got this in production in 4 data centers now, and we're going towards a 5th in a couple months. So that's exciting stuff. And so some of the possibilities that we've been able to do with just Cumulus and open switching in general is we can treat these more as like a Linux box. And one of the cool things is the able to kind of trigger Jenkins pipelines through the zero-touch provisioning feature. So once we've initially bootstrapped the switch and installed Cumulus on it, it does another DHCP request for some scripts to call. Instead of calling some script to do stuff, we have a hidden API endpoint which fires off a Jenkins pipeline. At that point, it does the package installation, the security stuff, license installation, reboots, and then throws on the a network configuration, and we get a cluster up and running in minutes. And so since it's the Linux box, we use Prometheus for metrics. We can just throw the node exporter on there, get your basic KPI stuff from the switch like it was just a regular Linux device. So we get memory, fan, heat, CPU utilization, interface metrics. And then we kind of started, taking things a little further. We've got, our own custom exporters, which let us know what the operating, the Cumulus version is, what we tag the versions of the network config that's on the network. And so if you have a config, we'll tag it as like version 1.0. And so we'll know like, hey, what version is running over here, what version is running over there. And then we can go, well, what are the differences there? If we see an issue, we can quickly identify the problems because, hopefully it's just as easy going, well, let's roll back from that version to another version. And the route table and peering metrics. And so we're able to export with Prometheus, what our route table looks like, how many routes are being advertised. Because we're doing IP per container, and I should have said that earlier, we do an IP per container from the server level, so we peer the servers to the top of rack as well. We use Calico for the /32 advertisements, and that all hooks into Mesosphere, which is what we're using today. It'll also hook up into Kubernetes. And so what we want to do is we want to keep tabs on what 32s are kind of floating around in the fabric from the application layer. We don't want 2 32s in the same space to be advertised. And so we can keep track of what the tables look like, how many peers are. There's a lot of flapping going on. There's a lot of growth. And so it's cool stuff. I really like having access to the Linux aspect of our switching. And so I wanted to include some compute cost comparisons in the DC versus the public cloud. And I know this is random. I can't talk numbers and stuff, but at least I can go and say we looked at all the costs, kind of tried to aggregate it from compute and disk and all that stuff. And this includes cost of employees and cost of the data center. All these numbers included from our finance guys. And let's say that that our Azure cost per unit is $1. For AWS, we're getting it for 76 cents, and in the data center, we're getting it for 22 cents. And so, there's obviously great value to, using the cloud. I'm not saying you shouldn't use the cloud. There's the use case and stuff, but there's also, if you can cut down the time it takes to deliver your application to the data center as quickly as you can deliver it to the cloud, then you can obviously see the benefits of keeping some of the stuff internally. So yeah, the next steps. We want to annually go back and look at what we're doing and reassess and be truthful with ourselves. Are all of our needs being met with the current models? And so are our network switch needs met? Have we hit some capacity? Do we need to expand the spine layer? Do we need to change the model types? Whatever. Do we want to go to Mellanox? Do we want to go to Broad? We want to reevaluate these things. Are the OS needs being met? Do we need to work with the vendors to get new features added? What is it that needs to happen? Are the server needs met? Well, that's kind of why we're here. When we went with Dell, we went with Hitachi and whomever, we're going to still kind of run into those same issues, and I really think it's going to be valuable for us to learn what we can here about what OCP can do, and see if we can get some of that kit in there and see what the the real business use case is there. Is it really saving us money on all of the back-end heating costs and power costs and parts replacement and all that stuff? So I'm really excited, and obviously let's continue to automate and make things as simple as possible. Sweet. Yeah. Let's open up for questions.
Questions, great, thanks. Yeah.
So on your underlay,
Sorry, please repeat the question.
Yeah, sure.
on your underlay after it is set up, what is the most common day two operation you do?
What is the most common data operation that we're doing?
Day two operation
Oh, day two operation.
on the underlay,
So I'm.
the network underlay. Like
Oh, hey, I talked with you guys the other day. Our day two operations, so you mean like as far as config automation and the like, it's evolving. We're not fully where we need to be. And so that kind of boils down to the point 4 here is continue automating, continue with the procedures of what it takes to auto-generate the configuration. We need a new leaf switch or whatever. Let's auto-generate that config, get it pushed out there. Because obviously we want to avoid manually inputting values on devices. We use Ansible today for pushing out configurations, and so I don't want to have to manually create what the Ansible variables look like. I want that stored somewhere and known about, and then have it automatically generated when a new device comes online. I mean, there's a whole lot of work that needs to be done still. I'd like to have it auto-discover when new racks or new management switches come online. So let's keep track of what LDP is doing, and if there's been changes, we'll try to reach out the device and see what's going on. What I would like to see happen is some of these open switches have redfish, swordfish. Like right now, these edge core switches, they just have console access to it. I would like something a little more interactive where I can, push to it and force a reboot force a reinstall to happen versus having to, log into console, see what's happening. And I know with Cumulus, you can run a command line switch and say, reinstall, but it's more involved than that, anyways. Yeah.
Hey, that was a pretty dramatic cost comparison you did on AWS and Azure and data center. That's different than kind of the mental model of kind of moving to the cloud. What do you say are the biggest drivers that are giving you the advantage of doing the data center versus kind of?
So we have a pretty large scale at the data center. We've got, I don't know how many, I thought it was like 15, but people are throwing other numbers around. So I mean, at that scale is where I think you really see the cost benefits. Yeah, so it's all about the scale of your installation. I mean, we've got tens of thousands of servers out there. We don't have Facebook scale, but we've got a lot of stuff going on. And so I think you need to keep evaluating. I remember when I saw, the Snap IPO, and I saw, what was it, $500 million a year of cloud spend. I'm like, you could probably put that elsewhere and really decrease what you're spending there. But anyways, yeah.
You mentioned 10, 40, and 100 gig speeds.
Yes.
Could you say anything else about that, or like what the link scales at which you need to do those are?
So, yeah, I'm sorry. So the question is, we talked about 100, 40, and 10 gig links. At what scale are we doing things? We've defined the cost to be a certain size because we were only using 3 spine switches at a given time right now. Obviously in the future we could expand out, but initially to keep the oversubscription, it's 3 spine switches, 16 top of racks, 22 servers per top of rack switch, and that brings us to like 352 servers per our Kloss install. So it's not huge, but when the time comes, at least it kind of allows you to expand out in that direction. Did that answer?
Do you have some copper connections in there?
Yeah, it's all fiber. So you want to know that? Yeah, we use DAC from the servers at the top of rack. The only other copper we have in place would be for the management connections to the 4610s, and so each server has their IPMI plugged into this management switch. The Axis top of rack switches have their management interfaces plugged into this management switch, and the management switch have copper plugged upstream. And so that's kind of the only place where we're using like spanning tree and stuff. Otherwise, it's all just layer 3/27s on the top of rack advertised into the fabric. So we tried to eliminate as many protocols as possible. So layer 3 and then BGP and Calico as kind of the overlay. Probably start looking into VXLAN. I mean, my ultimate goal here isn't just to have this be like container-centric. I want the rest of the networking group to be able to kind of adopt it. And so we talk about VLAN reach at that time. Let's go with like an open protocol VXLAN and get the reach that way and still allow us to use get ourselves away from the big vendors and allow us to use the cheaper switching, but better switching, and go from there. Did that answer? Nice. Oh man, believe it's single mode. We use for the 40 gig, it's LC. For the 100 gig, it's MPO. And I'm not super hip with the lights beyond that. I leverage my optics provider to kind of let me know the details there. Anyways.
All right, any other questions? All right,
Awesome.
Stegen, thank you very much.
No, this was nice. Thank you for coming. Awesome.